Hello all. It's been a crazy trip to here. Basically, our flight was delayed, so we lost the train. There was no trains because there's Semana Santa, so we couldn't get any trains, so we had to rent a car. So I arrived at 2 in the morning, and I have no room, so I had to sleep with Rainier, and Rainier snores, so I haven't slept much, but hopefully that will work. I could either talk in Spanish with Galician accent or in English with Spanish accent. They told me English with Spanish accent is okay. I want to thank the organization. I used to run a conference for many years, and I know how hard it is, so please a round of applause for all the organizers. It's great. And if I forget later, if you guys have any questions about Anyway components, about specific components, I have Rainier here with me from San Francisco. There's the guy there, the big guy in the front. You can ask him any questions. And so, for this presentation, I wanted to give you a little bit of an idea of where we were, where we are, and where we're going. I am one of the first engineers that started Lightning, so if there's any problem, probably it was my fault. And so what we're going to see today is a little bit of, I gave this presentation 2 weeks ago to all of the architects at Salesforce, and imagine a room of 400 very senior architects, on which 90% of them are back-end based, right? So we're going to kind of see a little bit. I want to frame a little bit what are the problems on the UI and see where we were, all of the history a little bit, and then how we're going to solve some of the problems with Lightning Web Components. And so, again, this talk I gave it like 2 weeks ago, and most of the people I was in the room with, they work in this beautiful data center, right? Whether this is our first-class data center or the third-party data center, it's all about services, API, Apex, things like that, right? All of those things happen on a data center. But the UI is kind of a different animal, right? Normally, a data center is somewhere in Europe, right? In this case, the problem is our users, our customers are all the way on the other side of the Atlantic, right? Or the other side of Europe in this case. And here is the interesting part. When I did this presentation, I had to clarify, because I remember there's a room full of Americans, and when I say I'm from Spain, they say, oh, Madrid or Barcelona. And it's like, no. You know, Spain is bigger than Madrid and Barcelona. You know, I had to point them. You know, Madrid and Barcelona, those little dots, and Malaga is over there, Galicia is over there. So, you know, I give them a frame because sometimes they kind of, and of course I have to tell them, you know, that prosciutto and jamón are different things, right? They don't realize that the jamón is vastly superior, right? So I had to explain them this. This is actually a presentation I gave to everybody, to the co-founder and everybody, so it was fun. Now they know. So going back to our real problem. So the fundamental difference when we talk about UI, right, and especially in the Salesforce ecosystem, we're used to the server. Basically, all our bytes have to be sent from the data center to whatever the client is in a network we don't control. So we're going to talk about what are the challenges from the UI. And the first challenge is the connectivity, right? So our UI, you will say, if I'm connected from a rural area, right, we'll have 3G sometimes, most of the time 2G. A little bit of 4G, but no offline. Most of the time we will be connected once we are in rural area. But also you say, well, if we're in the city, what problem is solved, right? Well, sure, we have 4G connection, right? But actually, we get into the subway, we get into the bus, and probably we lose connection, right? And so we have to build UI that works from the super fast connections to the no connection at all, or even offline for most scenarios. So that was the first challenge, how we build UI in general, but also at Salesforce, right? The second problem we have for building for UI is, you know, and some people don't realize it, hardware is a challenge, right? We're all used to these beautiful, wonderful devices like the MacBook, right? But the reality is most of the web has this, you know, not so advanced devices, right? Like you go to India, that's kind of like 90% of the population will have. And we have to build UI that works on the left and on the right. So again, remember this presentation I was given to all of these backend developers. They are used to have control over the hardware and everything like that. So we're trying to tell everybody, hey, UI is kind of more complicated in that regard. So just think about how faster this can parse HTML. Now, another interesting part is the software is actually a challenge, right? On one hand, we have our awesome, beautiful, crazy Chrome, which has amazing amount of things: multi-processor architecture, cross-platform resource fetching, DNS for resolution, page re-rendering, TCP pre-connect, speculative Chrome predictor. It's insane, right? You have 1,000 developers working on Chrome, and it's running really, really fast, right? On the other hand, It just won't die. It just won't die. Anyway, hopefully next year. You guys are going to help me with this, right? We'll kill it. So we have to support a lot of different browsers, right? And it's really, really hard. And a big challenge we had spent a lot of time in Lightning Web Components, we'll see later, is I11. Now, the most important problem of all is our customers, right? Our users. Remember, we have to send all these bytes to the wire. And at the end of the day, we have to do it really, really fast. And this is kind of a canonical representation. If we spend more than 300 milliseconds, between 300 and 1 second, this is kind of the verge where people are going to basically switch to other things, right? And this concept of Salesforce means bugs, customer complaints, and attrition, right? So we have to be faster than that. So how do we build a UI that has to solve for all these different set of constraints and yet make it fast, right? How many of you know this page? Hopefully nobody here. Right? That was our awesome Salesforce UI, right? And why was this was really good? Remember, it was 20 years ago. The reason this page was really good is to remember the constraints I talked about. It was really good at that, right? It was very little network. You need very little hardware. And the performance was quite all right. Why? Because most of the work was happening on the server, right? This is a server-side architecture where everything you see on the screen happens in one round trip. You go to the server, you build the page, and you're done, right? So it was really good because it allows these constraints to be very, very low. On top of that, we build our amazing customization. Right? That's why we are here, right? The amount of customizability that you can do, it was awesome. And so that's why Aloha was successful for pretty much 15, 20 years. Now, as you can imagine, after a lot of releases, things got a little messy, right? Imagine this monolithic application in Salesforce is basically Java. It started to get a little bit intertwined, right? Like we have some JavaScript with some PL SQL living together with some JavaScript and CSS, and it was kind of a little bit of a mess, right? There was this pattern that is called primordial stages. It's all intertwined together. And so the problem was literally we had no boundaries, right? So basically we ship all of this stuff through the client. We kind of server-side generate some HTML. We ship it, right? And again, that was great for a long time. But we had to define some boundaries. So what we did, like 5, 10 years ago, you all know this, is we separate that. It's like, you know, we're going to build components. We're going to separate the data. We're going to separate the component, the markup, the CSS, and we're going to build components out of it. And that basically means that now we can ship more encapsulated UI, right? And so we can actually scale better because now we have some boundaries, so it's easy for us to move to a more componentalized model. And what does this look like? Well, you all know this, Visual 4 and Apex, right? It was super, super successful. Why? Because it allows you guys to customize the UI however you like, right? With Aloha, it was a little bit constrained with Salesforce Classic. Now, with Visual 4, it gives you the power to build your own UI, tapping into all the data from Salesforce, tapping all the UI from Salesforce, and it was great. How many of you have written Visual 4 and Apex? All of you, right? So that was super successful. And so why do we have to move? Like, why do we build Lightning? So something happened in 2007. Anyone want to guess what it is? Mobile came around, right? And so when mobile came around, the expectation was no longer, I'm going to go to a page and click on something and refresh the page and do that again and again and again, right? So mobile brought interactivity, right? Mobile brought the customer will now want to click on something and see it immediately, right? Customer wanted to navigate from one page to another seamlessly. So it means that we have to shift our paradigm, right? We have to basically build more rich interactive pages, and server-side architecture was not able to fulfill that. And so we have to change our architecture to build something more client-side based, more interactive. And now the problem is, this was 2007. Actually, it was actually 2004, but this is kind of what the web looked like in 2004, 2007, right? Most of the stuff, there was almost nothing standardized, right? It was ES5 or JavaScript 5. Basically, we have to build all of that stuff ourselves, right? We have to build basically libraries like jQuery or Lodash, things like that, right? You all know those. You have to build a lot of stuff that happen to run on top of the browser because there is no standards, right? And so again, what do? Right? We have to build this massive customized application, customized platform for all of you. But there was no React, there was no Angular, no Ember, no nothing, no Vue, right? It was 2004, so we had to invent our own thing. And we had to make it scale. We had to allow you guys to write components on top of it. So we have Aura. And so remember, Aura was, the fundamental ideas behind Aura were good. A component model, right? very declarative, so it basically allows us to transition from Visual Force very easy to more like a JavaScript environment, or in a declarative way. And it was metadata driven, right? There's still Apex and still sorry, not Visual Force, but Apex. You can still use all your stuff. So at the time, the ideas were good. Implementation, we could have done better. Or I was not I came to Salesforce after I was there, but I've been trying to fix it for 3 years. And as we're trying to fix it, as you remember, the problem now, we were from a server-side server architecture where everything is basically pretty easy to basically do the first pane, right? So we send some HTML, we parse some HTML, CSS, we get the first pane, and then we have first interaction, pretty fast. Now, with the new model, we have a lot of JavaScript to process, right? So Aura was a big abstraction on top of the browser that was spending a lot of time just processing stuff, right? So we spent a lot of time working on performance, try to make it faster, try to make it better. Now, the problem is, again, we invented Aura, we invented our platform, right? So we had to do a fork in the road. While the standards and the web was moving on, we were basically busy trying to fix our own stuff, right? And we did a lot of work, and Lightning, as you know, got faster and faster as we go along. But what happened was, while we were trying to fix stuff, the web moved on, right? 2015, Node.js appeared, JavaScript started to took over the wall, right? And then the standards started to evolve, right? So think about jQuery. Most of the stuff that was in jQuery back in 2005 now is implemented on the standards. Think about things like filter. Think about document query selector by ID. All that kind of stuff now is on the browser. And because it's on the browser, it's faster. Because natively, you can implement it way more faster than what we call userland, like you writing JavaScript code, right? So there was a shift. And now, we go from everything was green to everything is orange, right? Everything is now implemented by the web, right? And now we're in 2019. And we're still fixing, our proprietary system. And at some point, we say, we need to change something. We need to move on, right? So we knew where we were going to go, and the question is how we're going to get there. And that's kind of where we are and where we're going to be. Now, in 2019, if you think about it, Salesforce has grown a lot for the last 8 years. We have a lot of clouds. Probably you have seen, how many of you have seen this beautiful marketing picture? How many of you are in marketing? Hopefully none. OK. So we have a lot of clouds now. We have a lot of products, a lot of stuff. So now we have to cater our UI to not only one platform, but for many platforms. And we need to basically not be able to do the same mistake, which is going proprietary, going for our own stuff. And on top of that, we have a lot of customers to cater to. Right? We have developers. There's Laura. So developers care about several different things. Right? I want to be productive. I want to build in all the platforms in Salesforce, whether it's commerce or service or sales. I want to be productive. We have our partners in ISVs, right? It's like, I just want to build things once. Give me metadata. I want to build everything. And I want to just help you, help me, and vice versa, right? And then we have admins, right? Admins like, I just want to drag and drop, make my job easier. I want to build a builder. No, I don't want 17 builders, And there's our user, right? The user's like, I want things fast, and I want to use this beautiful, consistent, everything is amazing, right? And now on top of that, if you think about it, we have a different platforms, right? We have from the very sales and service out of the box to very communities with something like people can do with Heroku. So at the same time, we have a lot of stacks. We have the people working on Heroku, right? They basically own the whole stack. They own the framework, they own the design system, third parties, and customer, and components. And on the other hand, we have the sales and services where everything is out of the box. So the blue part, as you can see, the blue is what the things that you own, right? So in sales and service in SFX or Lex, you own the components, we own the rest. But we need to build an architecture that the components, regardless of where you build them, it can work the same. Again, from Lightning Platform to communities to Heroku, we want to basically build something that can work anywhere. Even outside Salesforce could work. So how do we build this, right? Again, 2019, or like actually a little bit early, but so how do we fix all of these things and help our customers on the UI side of things, right? And basically, that's how we build, why we build Lightning Web Components. So Lightning Web Components is basically sugar on top of the web standards. And we're going to see how that helps in all of this beautiful ecosystem. So think about this. At its core, the UI is basically about components, okay? Web components. So again, in 2019, if you remember the slides before, web components is standard. And the reason it's great is because it allows us to interoperate, right? Again, because is standards is the most way that we can be future-proof. It allows developer productivity because we don't have to search only on on the Salesforce documentation. You can go anywhere in the internet and search for web components, right? So we believed back in 3 years ago when we started lining web components that that was the right model because it really aligned well with our business, which is components that you can share anywhere. You don't have to be Salesforce for writing them. You don't have to be in Salesforce for using them. We believe that at its core, it was the right thing to do. Now, the challenge with web components is think about this, there are very, very primitive APIs, right? There are APIs that are very powerful, but they're very verbose. This is kind of all the code you will have to write to build a web component, right? So you have to write a lot of wiring with the template, the HTML, every attribute. Think about the very primitive APIs, and then you will have to build a lot of stuff to make one component work. So we need to fix that. We need to put some sugar into it. So what is that sugar? So on top of the web components, what we're going to add is what we call lining web components. And so what is lining web components? It's basically a layer of abstraction, a layer of sugar that, one, fix the gaps with the specification. As you know, Salesforce joined the W3C and TC39 a couple of years ago. Well, WCC very recently, but we're working with them for a while. And we have to build some gaps. For example, there is still some things in accessibility that are not quite standard in all the browsers. We've been helping making that gap go away. In the meantime, we polyfill it. Again, we have to support our friend i11, right? So we have to make web components and the latest standards work in all the browsers that we support. That was an insane amount of challenge. And we were the first enterprise company that actually allowed the latest and greatest JavaScript to run and web components run and be fast in i11 and performant. And there's all sorts of accessibility, security, internalization that we had to do to make this enterprise ready, right? So that is kind of LWC. Our goal with lining web components in 5 years for that layer to disappear. So the blue will get better, the orange will shrink, and eventually we want LWC to be a compiled thing and let the browser do as much as possible, right? So that was kind of in our 5-10-year roadmap is because what is standard, when I push the browser to do most of the work, which means it's faster, and LWC will become smaller and smaller, especially when we have to kill i11. That will be a great day. Now, this is kind of web components. I don't know, how many of you have built one lining web component? Half of the room? Okay, that's great. So, again, nothing proprietary here, right? Everything that you see here, it's standard. And so I highlighted a couple of things. So basically, instead of importing the HTML element, we have, again, sugar on top. You import lining element, right, which is our abstraction on top of web component. And we do things like decorators on the right, the API and track. Basically, that is sugar, again, to be able to make you more work faster, right? So API is equivalent in Aura to a public attribute, and track basically means make my property reactive. So every time you change the UI, automatically do that for me. And it's super, super efficient because now we can track things in a much more effective way. Now, as you know, there's one really important piece missing, especially for Salesforce ecosystem. Remember our admins and developers and ISVs, which is the metadata, right? As you know, Salesforce is all about metadata. Your metadata, our metadata, right? That's what allows us to move forward without breaking you guys. From a component perspective, it's the same thing. Metadata for a component allows us to basically do builders and design time tools and basically allow to do static analysis and do things like decoupling the data on APIs. It will allow us to do priming and preloading. We're going to see that in a second. Allows us to do offline, very important, as you remember from the constraints, tooling. So what is this metadata? Like, what does it mean metadata in the sense of components, right? So this is a component. Again, you don't need to really understand, hopefully you will do at some point, all of the stuff that's going on. But what we did with lining web components is we want to make it that we want to detect everything at static compile time. We don't want to wait for runtime. We want to make sure at build time we can actually tell you all these things. So for example, this is how now you will import a label. This is how you import a field. This is how you basically import a record. What is really important about lining web components and the way we have built lining web components is we want everything to be statically analyzable. So we're using ESX modules, as you can see. And the important part about ESX modules, for example, if you change your field, if you change the account.name, we can actually fail and tell you, hey, you have a component reference the account name. You have to change the reference before you want to change the field. Or, sorry, delete the field. If you change the field, we can actually change it for you, right? So you change the name, we'll automatically trigger those changes. And something that we cannot do in Aura, now we can actually do it right. Another things that are really, really awesome from LWC is the way you wire data, right? So you see there, again, I will encourage you to take a look at the docs and the documentation and the playgrounds. Consuming data is way, way more easier now. You can basically import, this is for example the family of your record API. You basically wire your records and you're done. This is the only 2 lines you have to do to actually wire data to your component. There's no more Apex wiring, Aura controllers. Now you can actually use 10 Apex controllers in the same component, if you will. And again, all of this is very declarative. And we'll see that in a second. So again, what is really, really important about this metadata-driven architecture from the UI is, imagine you have a screen, let's say like a home, like a custom object for account or opportunities. That is the view, right? So everything starts with one component at the root. And that component has a bunch of dependencies. And these children has dependencies, and its children has dependencies, and its children has dependencies, right? Now with this wire thing, and with the static analyzability in this metadata, what we can actually do is prime all of the content. Imagine be able to fetch your data before we actually have to render one component on the page. Amazing. Think about it. In Aura, the problem was you do a request and you load the data and then you render the next component and you go to the network again and again. So there's this waterfall effect, right? With this now, we can actually predict which data you're going to get. We can actually build tools like, oh, if you're a customer X, maybe you're going to use Y, so let me actually preload that data for you. Doesn't matter if it's data, metadata. So on top of that, we want to build something that we call the container. And so think about this. Imagine that you can build your components and put them anywhere you want. Not just through learning out, but you can, again, this is web components. You can have your Angular app and embed your components that you build at Salesforce and put them there. You can build it in, put it in communities. You can put them in the marketing cloud. You can put it anywhere you want. You can put it outside Salesforce. Again, there's nothing proprietary here. We can build server-side rendering. We can build, on top of that, service design system, routing, bootstrap, you name it. So how this works, think about this. A component basically depends on some data. Let's say you are a record API for creating records, deleting records, things like that. And again, this is statically verifiable. We know you're going to get that data. So the component is basically saying, hey, I need a record. This is my record ID, and I'm going to give you back a Salesforce record JSON representation of this. Now, what is interesting with this decoupling of this wire and having data completely separated from the component, that my container, in this case, for example, if we're in SFX on Lex, service and sales and service, we can have an implementation that talks to our core APIs. We call it core, but it's basically our monolith foundation. Now, if we are in communities, the same component can work, but maybe they are calling the components, the commerce or the communities APIs, right? Or if we are in the world of, Heroku or whatever other third party, you can actually implement some MuleSoft API or whatever you want. The component still can work because now we have decoupled the data from the component itself. Super powerful, right? It means that your component can run anywhere. Just basically changing the container will change the implementation details of some of those dependencies and everything will work. So again, these are the fundamental principles that we want LWC to be built on top of. And so at the end of the day, our goal going forward is to basically give you all everything we build. So we want to build more open source. We want to build you all the CI/CD tools. You saw a talk earlier from Felipe and Peter about the testing. We want to make all of the stuff open source. There's a lot of things coming on the pipe that go into that direction. Not only, again, just the components, but basically the tools, our engine, how everything. So you can actually not run it on Salesforce, but run it anywhere. And of course, that builds a better ecosystem, right? All of these talks that we saw before, all of these partners, now they can build more awesome tools. Why? Because they can tap on the power of open source. We're using Jest for testing, right? We use a lot of open source tools internally, like ESLint and Babel, a lot of stuff that we're trying to contribute. We're contributing to Babel open source model. We're contributing to ESLint. We're going to see an announcement soon. So that is what we want. That is what we're going towards. And if you think about it, if you remember from our marketing slides, now we have our beautiful customers, beautiful ISVs, beautiful partners, and all our stacks. And what we really want is everything to be aligned, everything to be connected, not only from the data perspective, from the UI as well. And we believe with the new stuff that we just GA, which is Lightning Web Components, and the new alignment we have between all the clouds and all of the products, we can actually get there. And so again, it's not going to be an easy journey, but that is the direction. And so my talk was mostly very high level. I would love for you guys to now ask any crazy questions. We have Rainier here if you guys have more particular questions about, and then we have our evangelists as well there. And that is all I have. And now, questions. And I'm going to leave this here so you guys can completely be entertained by it. Thank you. Come on, don't be shy. I know there is some shyness in Spain on the beginning, but I know after a couple of questions, people get into it. No? No questions? There's a question. Give a t-shirt to that amazing person.
Can you hear me? Yeah. Okay. I didn't understand the part of the priming or prefetch the data, changing how the data is loaded. You said that in Aura, you have to do the request to the server and bring the data, but with this new architect, it is different the way of loading that. It's faster, it's better, no? But I didn't understand how that is done, how it's different right now.
Yes, okay, so in Aura, right? How many of you are familiar with Aura? Most of you? Half of you? Okay. So in Aura, you will build your Apex controller, right? You will wire it, you will say execute action, run, go to the server. So the actual call to the server is the same, right? But in Aura, there's no way for us to know, anticipate what the component is going to do. So the difference now is when you declare this wire thing, this wire primitive, on the server, imagine that you loaded the page. In the Aura world, you will load your page or your component. Let's say you get some data. When the data comes, you will render more components. Like if the data is there, render a for loop, do more stuff. What we can do with this thing, there's nothing from a runtime perspective is the same. However, what we can do is when you declare that wire, we can say, oh, I know you want to get that record and this projection of data. So we can basically say, okay, let me fetch that for you. Now we can actually know that there's a children on your tree that is based on that data is going to actually need these other things. So what we can do is build that tree of data ahead of time. So basically you are declaring declaratively, hey, this is part of the metadata. I know I'm going to get this record. I know I'm going to get this list of records. So the difference is now we can actually know what you're going to get. So instead of having to go to the server multiple times, we can say, oh, I know you're going to get this record, but after on your children, we can actually infer that there's a bunch of other new data API endpoints that you can hit. So think about it as optimization. So if you don't have that layer, you will do kind of the same thing. Like you're going to get the call Apex, same thing. But with Wire, you have two things. You have the caching for free. So you don't have to take care of the storable action and figure out the refresh, like 2 seconds, right? So we do all that for you. We do all of the, if you have another Apex component somewhere else that does the same thing, we can actually cache and do cache coherence on that thing. But the most important thing is we can actually do a lot of prefetching for you. So we know the component is going to get. So we can, for example, when we load what we call FlexiPage, the whole record home, we can do one request to fetch all the data once. So while we fetch the component, we fetch it all, and then we don't have to go to the server again. So it means that the pen can paint in one go, right? And so we can parallelize on the server, the performance gets so much faster, right? And the goal with Wire is, right now we only allow you to use our own stuff. In the future, what we want to do is, once you have your API, there was a talk from Eduardo before, if you define, for example, your API MuleSoft, or you have your metadata of RAML or spec, we can generate the Wire for you. Then you have to write a line of code, and we can actually preload and do all the stuff also for you. So the goal is if you don't have the metadata, the runtime is still going to be the same. But because of the ability to fetch that ahead of time, we can do a lot of optimization, and we can allow you to do optimization as well. In the future, what we want to do is, because we have all that data, we can prime all of the stuff. You can say, hey, I want you to prime, because my customers are on the field, I want you to prime all the opportunities for the next week. So we can basically get all the metadata so you can be completely offline. So it's not that changes. It's basically an additive layer that allows us to spider and do a lot of more smart stuff when it comes to basically fetching data. Does that answer your question? More questions? Another question over there?
Thank you. I'm going to ask something that I'm not familiar with Lightning Web Components yet. I used to work with the what is now our components, so if this question is obvious, just say, yeah, it's fixed. In my experience, like by how the old Lightning components were served when working with Lightning Out, there was issues caused, for example, in Apple devices with the certification, because there were several levels between serving the actual component. So usually they blocked it because it identified as a malicious script or something equivalent, and there was no real workaround for it. Do you think that the switch to Lightning Web Components will resolve that, or?
So you're talking, it's more a problem from the connectivity part of it, like the authentication and things like that, or?
for the certification, basically ensuring that that if you have like a certificate, a certificate, that the script that you're serving is actually part of you and not like some tracking script from an ad that you have.
So the current version of lining out is, even with web components, the same. However, what we want to change is because web components, lining out will become just a web component. In terms of identification community and authentication, I believe we will be able to simplify because now we have Shadow DOM, everything is more encapsulated. CSP rules and things like that are still going to apply the same, but I believe we can simplify a lot the protocol between the client and the server. I don't think we're going to change fundamentally much in the terms of certification and things like that, but I believe because of the encapsulation, it will allow us to remove some of the burden, hopefully, but that's something that we will be working on probably this fiscal year to make lining out just a first-class citizen as a web component. So the bootstrap is going to be much faster, and the interactivity on other pages will all be much more easier, and we're going to allow more things because now we have a boundary that is built on the browser to be able to communicate back and forth. So I don't think we're going to significantly change much on the authentication, but I think that was going to allow us to do some minor tweaks to make it for sure faster and more embeddable with less constraints. That's hopefully the case.
Thank you.
Other questions over there? And you guys, any component question, we'll have Renier here, so we'll be happy to answer.
I have a question about dependency management. So traditionally on Salesforce you have previously was all of the code was in the org. Now all the code is in the source control. Use DX to deploy the code. But the project in your source control is the whole project, all of this. And if you have any dependencies, you typically, if it's a managed package dependency, you install the managed package. If it's not a managed code, then you'd have to somehow include it in your project and to deploy into the same org. Now with Lightning Web Components, you start utilizing NPM to pull down things like Jest for testing, and also LWC, engine, and all of that. All of these type definitions, they also imported from NPM. And the question is, how would I manage my Lightning Web Components dependencies? How would I distribute my Lightning Web Components the way that I could import them into multiple projects from things like NPM? At the moment, the SFDX project has a certain structure, and the Lightning Web Components must reside in main defaults or some other projects, LWC folder, which is where they're found and recognized as the Lightning Web Components. But if I just pull them down from NPM, they go into node modules, and DX tool would not recognize them from there. They would not be able to import. So is there any solution alternative to this, or is there anything in the horizon and in the pipeline maybe coming soon?
Do you want the short answer or the long answer?
I want an answer, yes, please.
Okay. But which one? Okay, so the problem with raw NPM modules is that the resolution system for Node, as you know, when you do require something, is using the private or like not proprietary CommonJS resolution, which is look at my node modules. So that's something that we don't want to be invested in, just because first it's only for Node, right? And second, I believe if I let you bring all of the components, your bundles in Salesforce are going to be 700 megabytes big, right? So we purposely wanted to get very restrictive on the beginning, right? So today what you can do is build any package as a ESX module or use it as a resource, and that kind of solves the problem. Now that is kind of a middle term. What we want to do as we go open source and everything is open source, we want to allow you to basically build some components or like build a package of components or package of utilities that are actually NPM. You can bring them through NPM, but they are basically based on web standards. So there is a new format that is coming to the specification that is import maps, which is when you import something, that's something that the browser is interested in implement, and Node is actually also interested in implement. So instead of having to go proprietary and having to figure out how you resolve those dependencies, we're going to be more implicit. So we want you to be able to tell me these are the dependencies they want. So right now, you're right. So the way you will do that is by, let's say you want to bring Lodash. You have two options. You kind of build Lodash as a resource, and then you do a request through load script, you get it. Or you just build an ESX module out of that and you use it as a component, right? Again, a component is now an ESX module, so you can import and export anything and it will work in your org, right? So you cannot just automatically bring any NPM package and will be recognized. In the future, we will allow that with very specific constraints. We don't want you to magically get something from NPM and get it on your org, because again, we believe that's a bad practice, and again, it's not standard. But as the standard evolves, and we're working with the spec on those two regards, we do want you to bring some of that. I don't think it's going to be always 100% out of the box, but we're going to probably have some plugins on TrailDX that will allow you to do that conversion, but you will have to explicitly probably ask with dependencies that you want and kind of have to make sure that those dependencies have a specific format, right? So as the standard evolves, we will support those, but certainly we want to avoid you bringing, for example, I don't know, Lodash and bringing 75 dependencies underneath because there's 700 packages, right? So we really want to avoid that, and we just cannot scale our platform when you have hundreds of megabytes uploaded to the database. So our goal is to get you there little by little. Another side way I'm going to comment is we want you guys to do local development fully. We don't want you to have to save to the database, push the component, do the test. We want to bring everything locally. The metadata plus all your components, be able to run like sales services, communities, whatever stack you're in, completely tested locally. Even mock your data, mock your metadata. That's where we're going. It's going to take us a while, safe harbor. But the idea is to bring more and more of the ecosystem as you go for your local development, so your CI/CD can test everything locally without having to push to Salesforce. Hopefully that answers more or less your question. We can talk later. More questions? Yes.
Yeah, before you were talking about with the wire service about prediction and prefetching, and I was wondering, taking that into account, that for example you have two Lightning Web Components, both for the account object, for example, and they both use the UI record API to get the record. For example, if both of them use this API, but both fetch different fields, really the prefetching will like make a single request to the database, even though any of those are really fetching only different fields, really will fetch only in one single request.
Yes, so it will basically do the combination of the projection, and it will do one request, and what is more importantly, if any of those components change the record, you will see the changes live. So I think we're trying to get GA soon, the live CDC, live beta. So you change, any of the components change that record, any other component that is connected to the same kind of record will automatically get the changes without you having to write one single line of code. So yes, the idea behind the wire is behind the wire is sitting LDS or Lightning Data Service, and that is basically our glorified data storage management, right? So that layer will take care of caching, persistence, basically figure out, oh, there's 7 wires and there's actually a child relationship between them. So an opportunity might have an account or vice versa. So actually we'll be able to track all of those dependencies as well for you. So your answer is we will be able to optimize all that. And so cache all of the pieces directly. So if we know there are 7 components that are going to fetch different parts of the record or even different records that are related, we'll be able to do one call, fulfill them all at once, give you the data, but still be able to cache things independently. So either of the two could change the projections differently and still will work in a cached way. More questions over there? They're very quiet. I was looking in time. I speak very fast in English, so that's always a Spaniard problem. No more questions? No more questions? All right, if you have any questions that happens at some point, I will be around, at least for today, if I know I'm sleeping at some point. So, awesome. Thank you very much.